Welcome to Systems of Linear Equations lesson number 5. This is the video that is going to kick off our start to the applications, the problem solving of systems of linear equations. And so we want to know where or why would we use systems of linear equations. And we've seen a little bit, or we hinted in one of the lessons, the one with the burgers and the salads, trying to figure out or solve problems sort of like that, where you have two unknowns, but you know two pieces of information about them. And usually it's, you know, a quantity, and then you know sort of what the amounts of each are, and you write an equation for both of those. And so all methods of solving the system are valid. You can graph, or you can solve algebraically using substitution and elimination. And so I'm just going to pick and choose throughout this lesson which one I'm going to use, but you're welcome to use others. And so the steps are always the same. These flowcharts tell us what sort of process would you use for any problem. And so in step 1, we always are going to read the problem and introduce some variables. X stands for this. Let y equal this. Write a system of equation, or systems of equations. So you're actually going to write two equations, usually from two different sentences, involving the variables, in which you're going to set up a system so that you can solve, and then so you can answer the problem and verify your answer against the context of the problem. And so we're going to sort of divide up here into some number applications and money applications. And I'm going to go through class example 1, 2, and 3 with you, and I'm going to leave number 4. Okay, so I'm going to do number 1, 2, and 3. That covers an area problem, a money problem, and this mystery number problem. So I'm going to start reading this, and then I'm going to follow through the steps. The difference between two numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. And so step 1 tells me I need to introduce some variables. I'm seeing them use the words, or there's two numbers involved in this problem, but there's a larger number and there's a smaller number. And so I'm just going to say let x be the larger number and let y be the smaller number. Okay, let x be the larger number, let y be the smaller number. So I'm just going to go up here and write, oh, larger number was x, smaller number was y. And this one, the first sentence didn't really say large or small, but it does say the difference between two numbers is 9. This is going to draw on some math vocabulary. It's going to come back to us that difference means to subtract. So when you subtract these two numbers, you get 9. Well, if you're going to get 9 and not a negative number, you should be going the bigger number minus the smaller number equals 9. Okay, I got one equation. The second equation says the large number is. The large number usually is means equals. I'm just going to check, keep reading, and then I'll come back and check that. The larger number is 3 more than twice the smaller number. So it does make sense in this problem. X equals my larger number, 3 more, 3 plus something, 3 more than twice my smaller number, twice y, 2 times y. So I have x minus y equals 9, x equals 3 plus 2y. And so I'm going to choose a method that I would find the simplest, or I would like to use. And so personally, my favorite method is elimination. But I can see some problems with that here because, I mean, I got x lined up, but my equal sign's in the wrong spot. Numbers are not lined up, and y's are not lined up. And so I can see an easier method, and that would be substitution, because these aren't in the form of y equals either, so I don't want to graph. But I do already have an equation written in terms of x. So really, I could replace this x in the first equation with 3 plus 2y, since x equals 3 plus 2y, and I already have an equation in one variable. So that's what I'm going to do. I'm going to replace x with 3 plus 2y. Then I have subtract y, and that was equal to 9. I'm using this replacement here. Here was the replacement on x. So x I replaced with 3 plus 2y minus y equals 9. 2y minus y is just 1y. So that 3 plus y equals 9. Subtract 3 from each side, and I see y is equal to 6. I get to go back to any equation I want. This one's really easy to solve. It tells me exactly what x equals, so I'm going to go x equals 3 plus 2, and now my y value is 6. 3 plus 12. That tells me x is 15. And so when I go back to answer the question, it says find the numbers. I might want to write a sentence or say the two numbers are 15 and 6. Okay, and so that's what I like to call the mystery number problem. A nice easy problem that doesn't make it too hard for students to connect variables to the words, because it's mathematical words, and yet we're just comparing x and y, which now are two mystery numbers. Okay. The next one I'm going to look at is at the top of the page here, class example number 2. This is what I would call an area or area perimeter problem, rectangle problem, something like that, where it says the perimeter of the rectangle is 40 meters. The width is 4 meters less than the length. Find the dimensions of the rectangle. And so right now I want to try and define two variables. So I'm looking here and I'm seeing, perimeter, I'm seeing width, I'm seeing length, and something that I would connect there is that perimeter is found by adding up widths and lengths. So that could help me. And I have to write two equations. And so when I write two equations, I have to first define some variables. And then I have to basically look in my question. There should be two sentences. Look at those two sentences. You should have your two equations. And so I'm going to focus over here for a second. I'm going to say let x be the width of the triangle, or width of the rectangle, not the triangle. And I'm going to say let y be the length of the rectangle. And so the width is actually 4 meters less than the length. So I'm going to say width x is equal, x equals 4 less. That means subtract 4 than the length, which is y. So I can rewrite this down here. X equals the length minus 4, 4 less than the length. And my second sentence here is the perimeter. And so I might want to draw a picture to help me see this perimeter type problem. So if I say here's my rectangle and x is the width, y is the length, I could draw a rectangle like this. And so I know there's, of course, two sides that are going to be the length of x and two sides that are going to be the length of y. And so if I wanted to find the perimeter, I would say, well, you go x plus y plus x plus y. You add up all the sides. That's what the definition of perimeter is. The sum of all the lengths of the sides in the shape. So I go x plus y, but I can simplify this a little bit because there's two x's and two y's. So I can go 2x plus 2y. And I was told the perimeter of this rectangle is 40 meters, but now I know perimeter 2x plus 2y, that's the perimeter, that had to be 40 meters. And so now I can solve problems I can choose to go to elimination. I can do substitution, which would be really easy again, but I want to show you another method. So I'm going to try and show you the graphing method in this case. And so I want to solve by graphing. That's going to be my choice here, because maybe I'm just not in the mood for algebra and I just want to graph. So the only kind of difficulty with graphing is that all of these have to be in y equals. And so this one is not too hard to get into y equals, because if I add 4, I'll get y equals x plus 4, and I mean that I could graph into y1. That's in y equals. Now this one's going to be trickier, so I'm just going to pull this down here and manipulate this, because I'm trying to go to y equals, which means x and 40 have to be on the same side. So I'm going to actually leave the 2y alone, but I don't want the 2x next to the 2y. In fact, I'm going to take away 2x so that it disappears from my left side, and on my right side I'm left with 40 minus 2x. But again, the difficulty, this has to be 1 y equals, so I have to divide everything by 2. 40 divided by 2 is 20, 2 divided by 2 is 1, so 20 minus x. And so in y2, I'm going to graph 20 minus x. And so I'm going to pull this up on the graphing calculator so you can see what I will be doing and what I'm graphing. So I'm hitting y equals. In y1, I had x plus 4. And in y2, 20 minus x. And I'm going to graph it. And I just want to see if they intersect. And so I can see, oh, my calculator's graphed. The window's actually already pretty good. Let's go and see what my window is at. And let's see if I go back to standard. So I hit zoom 6, if I can still see it. No, I can't. So that window I did have was pretty good. I'm going to go back to something like that. I was at x from 0 to 25, or I think it was 24, but pretty close. And y from, we can go negative 10, or we can go to 0, and let's up that to 20 and see if we can see it. It looks a little bit better. Okay, good. Now I can see the intersection right there. I know that the solution to a systems of the equation is the intersection, so I'm going to go second trace, which gives me my calc menu. 5 for intersect. It's going to say first curve, I hit enter. Second curve, I hit enter. Guess, enter. Intersection. X equals 8. Y equals 12. And whenever I'm showing a solution graphically, I should draw a quick picture, at least to show sort of what I saw on my screen and where it was. So I just get a quick picture of what kind of looks like an X there, where the X value, or the point of intersection is at the X value 8 and the Y value 12. And I go back, I have a solution, I go back to the problem. X stood for width. So I'm going to say the width is 8 meters and the length is 12 meters. That would be the dimensions of the rectangle. Okay, or I could say it's an 8 by 12 rectangle or something like that, so that I know that I've answered the questions, that X and Y aren't arbitrary, because someone reading this problem, and if they skip right to your solution and they say find the dimensions of the rectangle, and you say X equals 8, Y equals 12, they have no idea what you're talking about. So verify or clarify, width is 8, length is 12. Okay, class example number 3 is the last one I'm going to do with you. This is a money application, so we can go actually right ahead and cross off class example number 4. I'm not going to give you one like that. The money application, these ones are pretty good too, because if you have a value of money in various bill denominations, so either $5 bills and $10 bills, or $10 bills and $20 bills, and you have 33, or a quantity of bills, you can say how many you have of each. And so the first thing you have to do is first say X is some bill and Y is the other bill. And so in this case, I'm going to say let X be the number of $5 bills in my wallet. Sorry, we should read through the problem first. That was my bad. So Gary has $260 in $5 bills and $10 bills. So you don't know how many 5s and how many 10s, you just know he has $260. But you do know that he has 33 bills. So some of those 33 are 5s and some of them are 10s. And so we're going to use those two sentences to sort of help us solve this. So sorry, now I'll go ahead and say let X be the $5 bill, or the number of $5 bills I have. Let Y be the number of $10 bills. And I'm looking at my first sentence. Gary had $260. And in those $260, if I was going to say, okay, you have 10 $5 bills and, I don't know, 10 $10 bills, you would say 10 times 5 will give me the amount of money I have in 5s, and 10 times 10 will give me the amount of money I have in 10s. And so I got to do the same thing here and say, well, $5 times the number of $5 bills he has plus $10 times the number of $10 bills he has equals to $260. And then I'm going to make a second equation from this quantity right here, that he has 33 bills in total, that the number of $5 bills he has and the number of $10 bills he has adds up to 33. And so I hope you see this distinction here, that this was the money value. That's why we're multiplying by the denomination $5 or $10, whereas this was the number of bills. Okay? And so I've purposely sort of set this equation up just so I could use my favorite method, which is elimination. I've made sure that numbers are lined up, equal signs are lined up, x's and y's are lined up, so that I can go ahead and eliminate one of the variables. But before I do that, I see I either need a 5x or a 10y. So I'm actually going to take this whole equation and I'm going to multiply it by 5. And I'm going to work towards eliminating x. So my new system, which is the exact same as the old one, just manipulated just a little bit to line up nicer. I have to go 33 times 5, which will give me 33 times 5 would be 95? No, 165. 165. And I'm going to go 5 times x, 5x. 5 times y is 5y. And so this is the equation I'm about, or the system I'm about to solve. I'm going to solve this system. And so I'm going to eliminate x. They have the same sign, so if I subtract that system, I will get rid of x. So 5x minus 5x is going to be 0. 10y minus 5y, that's 5y. And maybe for sake, I should just keep that where it is. The equal sign, lining it up all the way down. 260 minus 165, that would be 95. So 5y equal to 95. I'm going to carry my work up here. 5y is equal to 95, which means I need to divide both sides by 5 so that y equals 19. And so once I have y equals 19, I can choose an equation, my choice, to solve for x. I've already got y. I need the other half of this pair. I'm going to choose the number of dollar bills one, the 33. I have 33 bills. 19 of them are $10 bills. So I can go 33 minus 19, and I get 14. And so x is equal to 14, y is equal to 19. That's the solution to my system. I go back to the context of my problem, and I want to state what this meant. And so x was the number of $5 bills, so I could say something like Gary has 14 $5 bills. and 19 $10 bills.
Ms. Zook, if you're in the school, could you pop down to the office, please? Ms. Zook.
Good timing. I was almost done. Okay, we're done. What we need to do, the 3 examples from lesson number 5. This is our introduction for applications. I'm going to put your assignment up on Google Classroom. You can go there now and work on the assignment. And if you feel ready, you can go ahead and complete the exit slip.